Hey everybody. Okay, so this is my quick little introduction to inverse functions. This should be just about all the information you need to be able to work together on worksheet 6 in class tomorrow. So to start with, a two-part definition of what inverse functions means and what functions need, what properties they need to have to be inverses. So there's a graphic definition and also an algebraic definition. Okay, so when you think of inverse functions graphically, they are reflections of each other across the line y equals x. So for example, if I have, say, a line to begin with, and that is my f of x, then if I sketch its reflection across the line y equals x, that reflection is going to look like this. Right? There's one point on the axis of symmetry there, and then say if I take this point here on the axis and I reflect that over, I'm going to get a line that looks like this. Okay, so you can see the symmetry there, that there are reflections across this line y equals x. And one of the consequences, which we've talked about before, is that on the graph of f, if you have the point AB, then on the inverse function, you're going to have the point BA. Okay? So there's a graphic definition of inverses. They are reflections across y equals x. Okay. And there's an algebraic consequence to that. Okay, so here's the definition, just the strict definition of inverses. If I compose two functions together and the result is that nothing happens to the input, so if f of g of x leaves the input unchanged, and at the same time, if the composition in the other direction, g of f of x, also is x, then you know that two functions are inverses of each other. And that's the test that we would use. Okay. So three things that we're going to cover pretty briefly, and I'm going to send you a document with just a few examples, maybe 5 examples for you to try on your own. And if you can do those examples, then you'll be okay on worksheet 6. Okay. So the three things we're going to talk about are 1, how to sketch inverses, 2, how to find inverse equations algebraically, and then 3, do all functions have inverses? And maybe you remember some of this from Algebra 2, maybe not. So first, how to sketch inverses. Clearly, we know that there are reflections across y equals x, and so some functions can be tricky to sketch, and others are pretty simple. Let's say, this is how to sketch. Let's say we have a function that looks like this. The reflection of that curve across y equals x. So it's just a rough sketch for this one because I don't have any particular points listed there. But here's a way I can do it if it's hard for me to visualize. I can say, take a sample point on one curve and then imagine it being sort of thrown across the line y equals x along a perpendicular. And I can do that with lots of points. I can take this one and sort of toss it across the line on a perpendicular so that I get 2 little congruent segments here, 2 congruent segments there. So if I do that with multiple points, in any place where the curve crosses y equals x is just going to be a point on your new curve. Okay. Then I can sketch what the reflection looks like by connecting those points together. So that's one thing. That's a pretty simple exercise, just using the graphic definition of inverses. And then the other two things, how to find an inverse algebraically and do all functions have inverses. Let's talk about that for a second. Okay, finding an inverse, we're going to use the graphic definition of inverses to do it. So let's have a function defined this way. A rational function. Now, if I want that function's inverse, I'm just going to use the idea of the reflection. If this has the point AB, then its inverse is going to have the point BA. So I'm literally just going to, maybe you remember this, I'm going to switch the roles of X and Y. So it's going to look like this. Instead of Y equals all of this, it's going to say X equals Y plus 3 over Y minus 4. Remember, f of x is just like y. Okay, so I'm going to switch the roles of x and y. Then, of course, we don't want to leave the equation in this form. I'm going to want to solve it for y so that I could use it afterwards. So now I have to just solve this for y. I'll cross multiply. I get xy minus 4x is y plus 3. Then I'll bring the y terms together. Xy minus y is 4x plus 3. Move the 4x over. Okay. We factor out the y. And then we have our function. Right? So now y is 4x over x minus 1. And this is how we would say it notation-wise. F inverse, this notation means F inverse, not the same thing as reciprocal, even though there's this -1 exponent. Inverse and reciprocal aren't the same thing. Okay, so this is how you'll report your inverse functions. F inverse is 4x plus 3 over x minus 1. Okay, so that's the algebraic method to find inverses. And sometimes you can tell the inverse equation just from looking at